Well, hi, good morning, and welcome from the snowy shores of Lake Couchiching. Yes, I woke up this morning to snow on the ground. Oh, my poor cats. My older cat, he gets it. My younger cat doesn't quite get it yet. Okay, so what are we going to do with this radio now, which is really getting to be a pain for me. So yesterday I came in the shop here in the afternoon and just started jotting down some ideas of things I might want to test on this radio, or to try to find the next logical step going forward. And I'm not asking you to read all this stuff. The one that stands out after I wrote all this down and looked it over is the one I put an arrow on here: tracing. You know, I'd started tracing this radio and encountered the dead coil at the front of the radio. I never continued the tracing after changing it. So I think this is probably the number one thing I'm going to go on. Got all these other ideas here to look at. Now, yesterday on my scope, if you're listening very carefully, you heard me say I don't normally hook up the scope to the speaker during a sweep. So I had this weird thing on the scope. I'm just going to kind of draw it here as best I can from memory, and it'll look something like that. Maybe not quite like that. So what in thinking about this, why is it two peaks? Why is it kind of an S shape? Oh, it's something to do with the speaker. I suddenly realized that, wait a minute. The signal I was sending to the radio to generate this image is unmodulated. There's no sound in it. There's no signal in it. So it's just a carrier passing by the tune point of the radio. There's nothing in the signal for the speaker to reproduce. There's no program material. There's nothing. So how it is, I'm hooked up to the output side of an output transformer, the speaker side, and yet get these shapes coming out of it for a signal that has no information in it. So I think if I thought about this long enough, and I could probably tell a story right now about what this is, but I'm not going to, because I'm not quite sure. Another factor is, well, why is there two of these things in here, and what's going on? And so what I recalled, after working on this and thinking some more about it, is my sweeper works like this. It sweeps out at a rate I control. There's a setting. And then it shoots back and sweeps out again. Shoots back and sweeps out again. The shooting back thing is real. There is a carrier shooting back through the radio again, from the high frequency to the low frequency, right top of the band to the bottom of the band. And on the way back, it's going to affect the radio. The speed of this change of frequency is very high on the way back, of course. So the effect would be somewhat different. Is that why there's two peaks here? I've encountered this out and back problem, and a few times I've used the sweeper. Maybe this is one of them. Bottom line is, other than making some interesting images on the screen and getting me to poke around in the radio more and more, I don't think this means too much. So, not to worry about that. It has led to this long list of goodies here. So yeah, this is the talk about the non-blanking sweep, plus the sweep speed on the sweep generator I'm using is 1/10 of what it is supposed to be. There's something wrong with that sweep machine. It doesn't sweep full speed. So if I had it sweeping even faster, maybe out this way faster and back even faster, that might have changed the look on the screen. But nevertheless, because it's hooked up to the speaker, no. Which you can hook up your audio voltmeter onto the speaker and get an indication, but again, only if the signal you're sending to the radio is modulated, and you'd have to use a fixed frequency. Then you can't put a meter out here and sweep it. It won't mean anything to you. It'll pop around, but it won't mean anything. Okay, enough on that. All kinds of possibilities here, but tracing is the one I want to try. So we're going to kind of pick up where we left off and try to trace a signal through the radio and see where it ends up. Now also, I took the time to fish out the battery. The battery's in here now, soaking in water. I'm not sure it's going to do anything for it whatsoever. And I replaced the battery with this clip lead, so there's just a short through there. I suppose I could fit another battery in here, just any old pen-like battery or anything, but I'm not going to at this point. And the test we want to do we're going to do on a single frequency. So we're not going to use the sweeper. We're going to use this guy here. You know, this is quite the signal generator because it warms up right on the frequency you left it on and sits there and never drifts. Never drifts. And this other piece of equipment I have up here, this thing drifts for an hour before it settles down. Hey, let's hear it for military technology of the 1950s. 600. Okay, get my tracer going here. A little closer look at the tracer that I use. So this probe, this gray big probe, is not made big so it's easy to hang on to. It's big because there's a vacuum tube inside here. And the grid comes out on here. This is straight to the grid of a vacuum tube, this end. That means the impedance of this is extremely high. It would amount to, I guess, the capacitance in the tube, which might be a few picofarads or something. But in terms of resistance, this is an open circuit here. Again, on my tracer, I've got a couple of adjustments here. We'll start with this one. So this one controls the eye here, and the stronger the signal, my finger's not much of a signal. There you can see. And then this is the volume you're listening to. So I can turn the volume down. You see, the machine's still working. We're just not listening to it. Unless I turn this up. This control is independent of the eye. This control, the attenuator, controls the eye relative to the signal. So sometimes what you want to do is you want to apply the signal, adjust this so the eye closes. Okay, it's just closed. And you call that calibrated at some point. We don't know what it is, but it's something. And then you carry on with the tracer, working your way through the circuit. You can look back at the eye, independent of the volume control, and find out if the signal you're testing is stronger or weaker than the one you initially set up on here. That's the whole idea of this thing. So how calibrated is it, in fact? I don't know. It's just me doing this. That's the story on the signal tracer. Inside this is quite a beast. Inside here is a radio receiver, but not the kind with intermediate frequency stages. This is a TRF radio receiver, and it operates in RF. Can you see RF there? Or AF, audio frequencies, if you flip the switch. And it'll tune the AM band, which is band B, and it'll tune through the typical range of IF frequencies that you encounter in radios up on this scale, scale A. So we could tune, for instance, 455. 455, I think is here, somewhere right around here anyway, if we wanted to tune it. So we're going to be operating, let's see, I've got this other signal generator at 600. Let's move it up to, let's say, 800. So my other signal generator is generating an 800 signal on the end of these wires here. 800 kilohertz. No, yeah, 800 kilohertz signal. So we set this to RF. I'm sure there's enough just leaking around and this thing's sensitive enough. 800 on this tuning dial is here, and that's B. Okay. So I'm just going to clip the so again, audio just affecting what we hear. And this guy will calibrate the eye. But I need to connect this ground. I got to do this right. Just a sec here. Okay. So I'm going to set this to bring this just closed. So full strength from the signal generator. Where? Here. Full strength from the signal generator results in the eye closing. And now we're just going to start proceeding through the radio here and see how this goes. In fact, put this about like that. I'll try not to get in front of it. Okay, push this off. This off. Put this ground here. We certainly don't want the other signal generator hooked up here anymore. Getting some superfluous wires out of here to reduce my confusion, you know, should something happen. Okay, so we want to feed the signal into the antenna. Simple as that. I've got the lights low in my shop, so the frame rate on my camera is a little low. Let's change that. Might have to change it back because it's hard to see the eye now. But better for me to have some good lighting here when I'm starting this up. Okay, so tracer. Radio up on its end. Plugged in. Anything else hooked up to it? Unnecessary scope you need here. Okay. Bit of a floppy wire there. I think we're all set. Okay, power on. $118. It's not turned on. Yes, it is turned on. It's on and full. So one of the tricks here is going to be tuning this radio to 800. It's going to be... Actually, you know, I'll tune the radio roughly 800, then I'll just sharpen everything up with the generators and the tracer again. So we're probably nowhere near 800. Let me look and just see where the capacitor is here. It's right down, so we're right down around 600. Let's leave it where it wants to be. The capacitor is so loose in there, it wobbles around. It falls under gravity, so down around 600. Okay, that's about the middle there. Sounds very distorted, doesn't it? Sounds like it's too much signal. Just cut it back. Now I've changed it dramatically at the rate coming out of the generator, so we're going to recalibrate everything here. There's not enough signal to close the... Oh, tuning. Still not enough signal to close the, nowhere near enough. Okay. Regardless of the fact it's going to overload the radio a little bit at this point, I'm going to go up. Factor of 10. Still not closing. Well, it is what it is. I don't want to turn it any higher. So what I will do though is I'm going to turn down the house lights here again. Give you a little bit better view of the eye. The calibration thing isn't all that important. So it's closing a little over halfway. Okay, other end of the antenna wire up on this coil. Should see exactly the same thing. Exactly the same thing. Coming out on the secondary. This one. That's it. It's pretty weak. Reaching the, it's terribly weak. Reaching the grid of the first tube. Oh, it's pretty good there. I must have just been touching the wrong spot. Let's check the calibration now. It's more than closed. So we've gone from not closed to on the grid more than closed. Well, that sounds good to me. Okay, coming out of that tube, I can't remember the plate number. I can't remember. So that's a 6. You know what? I'm gonna just bear with me. I'm just gonna pop up the schematic here on my own computer, just for me to see, not for you. And what do we see here? We see. What am I trying to do? So I'm looking for the plate. The plate of the 6SA7 is pin 3. Pin 3 is the plate. So we'll find out what's coming out on the plate by pin 3. Pin 3. 1, 2, 3. There's 3. This could be loud, so I'm going to hand on the volume control on the tracer. On the grid. Okay, set the volume there. On the plate. 1, 2, 3. Well, that doesn't seem too good, does it? What about this pin? What am I doing wrong here? Am I counting wrong? I am. That's not the plate, this is the plate. Okay, that's a little better. Especially I see this big capacitor going to ground, and it shouldn't be on the input side of the transformer. Okay, so let's check the calibration now. So we're pretty much the same as at the antenna now. So what happened to this? It's louder here. It's louder here than there. It's just possible that's the normal operation of this tube. That really what's happened is, and we can't tell with the tracer, is the noise level has gone way down. The noise in behind the signal. Okay, well, so we've got we still got something here, right? And it's not as strong, but it sounds nice and clear. Let's go further. So we will go on the secondary side now of this transformer, which is going to lead to the grid of the 6B8. The grid is the cap. Okay, going on the cap. Oh, it's next to nothing. Okay, so that's the cap. That's the grid for the 6B8. The grid is fed on the secondary of the transformer, whose primary is fed with this. So it sounds pretty darn good on the primary. But on the grid of the secondary, it's crapple. Surely it should be louder than that. So if we look at the plate, so this is what's going in to the 6B8. Again, this could be a noise, noise ratio thing. It's really good, but the level is very low. So we get fooled with the tracer. I don't believe it. Okay, then we would want to find the plate of the 6B8. The plate is pin number 3, which is basically the output. Pin number 3 of that same tube. 3. Okay, so there's the pin for the key. 1, 2, 3. 3's back here. 3. Well, it sounds nice there. Signal strength is lower than the antenna though. If you look, you see the eye? Again, it's a signal to noise ratio thing, so not to be fooled yet, but it seems to me to be going the wrong way. Now we're supposed to get all the way to the grid of the output tube. The plate of the 6B8 feeds into a transformer from here. You know what, I gotta look at the schematic with you and pull my hair out to go any further with this. So what have we found? We found the signal appears to be traveling fine. It's not noisy, but we don't have enough loudness here to really hear the noise that's below it. So it sounds like it's working properly right up until where I am now. Let's take a look at the schematic, and I'm going to whine for a while about this schematic. Okay, here's the schematic, and you know, in these radios, without looking at the actual circuitry right now, the typical thing in a radio like this is you have a mixer tube at the front end, and 455 or something like that is coming out of it. It's going through transformers tuned to 455, boosted by a tube into another transformer at 455, and then on to the detector and the audio circuits. You notice where my cursor's going? There's no detector in there. That's where things start getting a little bit strange. So we go back to here. Everything's kind of, you know, typical for a radio right up to this point, and then things get strange to me after that. So the signal is sent to the grid of this tube, and this tube is then amplifying the 455 RF IF signal, and it's going to be on the plate here, or in the plate circuit. I can see the plate circuit goes through this transformer and on back to the voltage supply. R3 is 50,000 ohms. So we have the RF signal in here, the 455, assuming there's a station tuned in and all that kind of stuff. That signal just, I mean, this is a tuned circuit here. So this could be potentially peaked to 455, and so you get some strength in here, and out here would be fairly strong 455, except it's snuffed out by this capacitor. Wait a minute, if you're snuffing it out, and this is hooked up to the grid, what has gone wrong? Why, there's no diode, there's no detector, there's no nothing here. The grid of the output tube, I told you I was going to rant a bit, is connected back to nothing but this. I'm not even sure what to call it. Okay, so we leave this aside and we look at the secondary side. What is the secondary side doing? The secondary side, if we follow it back this way, is hooked up to one of the diodes. So this is a rectified current flow in here, and then the rectified current flow is smoothed out a bit by this capacitor, and there's probably another one. No, this is it. This is the smoother. What is it? 14. Small, fairly small. 260 picofarad. And R7 is fairly big. 250,000. Well, in any case, this combination results in a smoothing of the, I imagine, of the half-wave rectified signal in here, so you get a bit of a DC, and then the DC is applied back, as you might imagine, to all these tubes. If this capacitor is not doing its job, this could be a bad deal here. This could be a bad deal. It's not a teeny tiny capacitor, but it is a mica capacitor, so I'm not inclined to replace it, but maybe that's going to be a target in the end. So in any case, that's what's going on here. We have output here at 455 shot into this side of this transformer. The transformed current is then used to operate the AVC on the radio. That all makes sense. But what's going on here doesn't make any sense to me. I don't know how do you do this? It just looks like 455 kilohertz is applied to the grid here. So so there we are. That's the end of my rant. I don't know how to resolve this so that it works. Good luck making the real radio work then. And so where we're at in the signal tracing, we traced the signal all the way along to here at the grid on the triode. When we get to the output, it's really extremely low. So this is the transformer I was struggling with yesterday, and I sort of made a half-assed attempt at tuning it. Could it be that this is so far out? How far out can this be? This is failing to resonate. I have to look for the 75 volts here to make sure that there's B plus on this pin. Ooh, not that pin, not that pin. This one, pin 3. Make sure there's B plus on pin 3. Let's do that right now. That's on my list on my bench. B plus on pin 3. DC plus 500 volt pin 3 of the let me just get this schematic on my own screen here. Pin 3. It's the right tube. Pin 3. 1, 2. This is pin 3. What goes on it? So there's B plus there. The actual amount is yeah, 200 volts, but on the schematic it says 75 volts. Wow, that's quite a difference. 200 volts. There's a screen in this, pin 6, 45 volts. 3, 4, 5, 6. Ooh, did I count that right? 1, 2, 3, 4, 5. Hey, no screen voltage. Coming from here. So you see there's 200 volts on this side of this resistor, and on the other side, not a thing. The resistor, looks like that resistor's open. Power off. Looks like we found something here. How many more of these? You know, I haven't gone through. I was going to do that one afternoon, come in here and just check all the resistors, which I occasionally do. So it's not on camera, and I almost never find anything, and this isn't going to work well with only one lead plugged in. Okay, so what's that resistor? It's a red something yellow, 20, probably 27K, 270K rather. Radio's off, power's off, meter's good. It was this one, wasn't it? Look at that. She's open. Oh, open. I missed that. Didn't I do a B plus test through these tubes? I did find B plus on, wait a minute, no, yeah, so I found B plus and left it alone, probably didn't look for the screen voltage. Way back when. Okay, well, no screen voltage, not particularly good for this guy here. Let's just nip him out. You know what I'm going to do? I'm going to put a clip lead on here because for all I know I'm going to be away for half an hour doing something in my house. When I come back, guess what I won't remember? Too many yellow clips in there. Okay, Mr. Ohm meter. My other ohm meter. Where'd he go? There he is. I'll check everything. Well, you don't get much more open than that. She's open. Wow, okay. A little late in the game to be finding that. And the number on that guy, let's just check against the schematic here. So this is wrong clip lead. Yeah. Pin number, no, that's a terminal strip here. It's between terminal strips. Okay, we won't figure it out. We're just going to replace it with what it was. And I said I thought it was 270,000 ohms. Okay. Let's see. Okay, I found one here. 270. Let's come out of something. Looks like I have a lot of sorting work ahead of me. I melded a bunch of my own resistors into those trays, but I really didn't look at what was in them in the first place. I made an assumption that whoever did all that tray work just barely long enough leads here. Good. No. These pliers I almost never use. Flat. No knurling, no grip on these guys. You know what, I'm just going to tack this in here with solder. That's not bad. Okay, a little springiness there. Nope, didn't work. Trying to get it to spring up against the connection. I have to push it a bit. Okay. Anybody know what I'm talking about? There's only me here. Yeah, it's gonna get too hot to touch. Join the bundle. Okay. Now, is that the guy that's been just ruining the party all this time? So this stays in because this is the battery short. And so where are we at? So we have a signal on the antenna. We have a bundle of dangerous solder here to get rid of. Danger. Noise making soldering iron to turn off. Volume way down because somehow I think this is going to come to life. Haha. How humorous can you get? Okay. Everything's good. Good. Plugged in, power on. What will we get this time? Oh my gosh. You little bugger. Oh, that sounds fantastic. Well, that's what this battery eliminated too. Quick, let's tune this radio quickly. Somebody get an antenna. So I should have found that resistor a long time ago. But I did not. Sooner or later, everything comes to light. Okay, there we go. This is an outdoor antenna. This radio is looking for a long outdoor antenna. This is the wire it comes with. That's a fair chunk of wire. Or that's what's left of the wire it originally came with. Let's pull this out of the radio here. Put it like that. Go this on there. So I may or may not want the ground on from my antenna. We'll start with it on. That was less than exciting. Okay, that's a good start. Alright, tuning this radio. Oh man, I'm going to have to face the string before long. No, not the string. Anything but the string. I need a stick. Stick, string. What kind of electronic shop is this anyway? Okay, so we're on the antenna. Let's see what we can get out of this guy now. Oh, I can't see enough. Okay, tip them a bit. It's quiet, but it sounds like a radio to me. Okay, so we're tuned in the low part of the band now. I'm going to hook up my loop antenna just to do that. It's just sitting here. try a signal generator on this for more. Oh, that's right. I said something about may not want the ground on. Okay, let's leave the ground off. Stick with the outdoor antenna, because I got a heck of a boost there. Let's just try and tune this thing again. Oh. I can hear a station there. There's too much noise in my shop. Let's try this. There we go. So again, the capacitor is swinging free. And I'm moving it with a stick, and when I take the stick away, it just goes like that. Back down to wherever it wants to hang here. Gravity assist tuning. It's stick tuning with gravity assist. It just caught a station and then. Okay, great. That's enough. Seen enough. That darn resistor. Should have found that much earlier. Now we got a radio that's actually working. It's actually working. Holy smokes. Battery doesn't seem to be necessary. Can't be sure of that just yet. So I could put a permanent wire in here. Get rid of this clip lead, because this is bound to be picking up some noise out here. Put in a shorter piece, and then try to align the radio again. See where we get this time. Great, that's great.